This is PSpice simulation tutorial series. In this video, we will learn how to create a digital design, which will be a counter circuit in our case using Cadence PSpice, configure the counter circuit and run the simulations. So let's get started. In the first step of this video, we are going to run OrCAD capture from Cadence program menu, select the license file and click over OK button. Once the OrCAD capture is ready, we are going to create a new project. To do that, we'll go to File, New, go to Project. In our case, we are going to name it Counter and let's save it on desktop. In my case, you can save it at different location. We are going to create a new folder, just name it Counter, enter and select the folder. Make sure you have selected the Enable PSpice simulation and click over OK button. We are not going to use any existing project. We are going to create a blank project. To do that, select Create a Blank Project and OK. Once the project has been created, we are going to place components. To do that, we'll go to Place, Components, and from here we are going to select Pull Up, right click, Place. We are going to place some pull downs. Then we are going to select the counter ICs, which is 74163. Right click, place. We'll place it here and we'll place another counter IC somewhere here. Right click, end mode. So this will be 8-bit counter. Apart from counters, we are also going to add a clock source, which will be digstim or digital stimulus, whatever you can call it. You can just select it and place. We are going to place it somewhere here. Right click, end mode. Now before going further, we are going to configure this digital stimulus. To do that, we'll just select the digital stimulus, right click, go to edit stimulus. And here you can find the stimulus editor. From the stimulus editor, we are just going to name it, let's say Digi. Then make sure you have selected digital clock and click on OK. Next, we are going to enter the frequency and duty cycle. So in our case, frequency will be 100 Hz and duty cycle will be 50%. Click over Apply and OK. Here we go. So we have configured our stimulus and it will look like this. Then close this stimulus editor. Make sure you have saved this counter.stl file and update the schematic. So our stimulus is ready and this implementation property will place it somewhere here, or if you want you can hide it by double clicking over stimulus, and here you can see this implementation property. We'll select it, go to display and let's click over do not display and click on OK button. Save the property editor and close. Next we are going to make the circuit using these components. I'm going to do that quickly. So as you can see, till now we have created this schematic and we have these pull-ups and pull-downs connected to input of this counter. So this is the 8-bit counter. At every rising edge of clock, this counter will toggle and after 255 counts, it will reset itself, alright, and begin from 0 again. So this is the entire design. It's a very simple 8-bit counter circuit. Next, we are going to set up simulation profile. To do that, we'll click over Create New Simulation Profile button. We are going to name it Counter. Click over Create button. So this will be a simple transient analysis or a time domain analysis. Here the runtime will be for 5 seconds. Next, we'll go to Option. And from the option, we'll go to Gate Level Simulation. And from here, you'll find this option, DigInt State or Digital Integer State. We are going to change it to 0. So by default, the digital integers will start from 0 state. We'll click over OK button. Now we are going to run the analysis. To do that, we'll click over Run Simulations. And here you can see the simulation is successfully completed. So in the next step, we are going to add traces in this simulation output window. To do that, we'll click over this Add Trace button. And from here, we are going to select all the outputs for U1 and U2 counters. So for U1, it will be QA, QB, QC and QD. And for U2, it will be U2 QA, QB, QC and QD. We'll click over OK button. Here we go. So you can just zoom in at a particular section and you can verify the state of counter. Next, we are going to save this project. To do that, we'll close this window and click over this Save button or press Ctrl S on your keyboard. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.